Okay, here we are in lesson 5.2. We're going to be talking about discrete and continuous domains. Make sure we got our fireworks on. All right, so remember what we talk about domain is our input values. So when we're talking about a discrete domain, it's a set of input values that consists of only certain numbers or intervals. For example, notice just these points, integers from 1 to 5. So 1, 2, 3, 4, and 5. Nothing in between. If we are talking about a continuous domain, then we can talk about the input values that contain all the numbers in the interval. So all numbers from 1 to 5, okay, looks like this. So that kind of looks like a and inequality kind of a thing, right, when we graphed that. So in this example from your book, here is the function. It represents the cost in dollars of X tickets for a museum. We want to graph it using this domain. So you want to make a table. Here's your domain. Input those values to get your output. Here's your ordered pairs, and you graph them. Now, after you plot them on the graph, are you going to connect the dots? Are you going to draw the line to connect them, right? So if you plot them as ordered pairs, you cannot buy part of a ticket. So we have to keep it as individual points, right? We call this a discrete domain because if I were to connect these two right here, it's to say that all the numbers like from 0 to 1 for number of tickets, like, a fourth, a half, a third, whatever, would all be possible input values. And they are not, because in the context of the problem, 0 tickets, 1 ticket, 2 tickets, counted quantities only. Okay, so this is going to have application that way. All right, so on your own, the function m is equal to 50 minus 9d represents the amount of money, m in dollars, you have after buying DVDs. All right, so we want to graph it and then determine if it is discrete or continuous. So let's make a table of values, all right? Let me just get several values for input. What do I want to do? Does negative numbers have any application here, right? If my input value is actually, this is actually D and this is actually M, we're talking about DVDs. So negative values don't have meaning. So I definitely want to start with 0. And I'm going to use whole numbers because would a half a DVD make sense? That might help us answer this question when we answer that question. All right. So if you plug in, 0, so 50 minus 0 is 50. Then we have 50 minus 9, which is 41, and 50 minus 18, and 50 minus 27, and 50 minus 36, and then 50 minus 45. Okay, so we could graph this. And I think I'm going to count by 5s here. So we'll say 5, 10, 15, 20, 25, 30, 35, 40, and 45, and 50. So it puts the very top up here, right here, as our first one. Then we'll count by 1s. So we'll have 1 and 41, which would be about right there. Okay, and then 2 and 32, I don't know, somewhere above there. 3 and 23, okay, and 4 and 14, below that. and 5 and 5. Okay, so here is our graph, and I could label them, right? I could label the ordered pairs. So since D is equal to DVDs, and I graph it, is it discrete or continuous? Should I connect the dots, right? Well, the domain is discrete. And should remain as individual points because you cannot buy part of a DVD. They have to be purchased in whole number quantities. That makes sense? All right, make sure you've copied that down, and then I will clear the screen. Okay, now we're being asked, I'm going to go ahead and do this too. You're going to conduct an experiment on the distance traveled at 55 miles per hour. So your input is time in hours. At 1 hour, your distance would be 55. At 2 hours, 110. At 3, so that's a pretty consistent speed if you're getting this, these output values. So basically, it's saying that, here, my time is greater than or equal to 1, and my time is less than or equal to 4, and that looks like an and inequality, which is kind of like a 1, which is less than or equal to t, which is less than or equal to 4. And so if we graphed that, that would be continuous. We would call that continuous. All right, because time can be any value between 1 and 4. Wonder if that's what they mean about time being a continuum. I wonder. Anyway, but it does make sense that we could have, 1.5 hours or something like that. So that is why we would graph it like that. So that's the context of the problem. Clearing the screen. All right, we're going to look at a couple more. In the first one, a 20-gallon bathtub is draining at a rate of 2.5 gallons per minute. So it started out with 20 gallons. It's decreasing at this rate. So my equation is equal to negative 2.5x plus 20. Or G, I guess, and this is M, yeah, that, I guess you could use G and M, but I'm using G as my Y and M as my X. So sorry about that. Okay, so what we want to know is to graph the function and decide if this is going to be discrete or continuous. Can we draw the line? So we're going to need an XY table. And let's use the value, I don't know, since it's halves, let's maybe use even numbers. So 0, 2, 4, 6, and 8. So obviously 0 would be 20. If you do 2, your output is going to be 15, right? Because you'll have negative 5 plus 20. If you do 4, you're going to have 10. Okay, because 4 times that would be a negative 10 plus 20. If you do 6, your output then would be 5, because you'll have a negative 15 plus 20. And then if you do 8, look at this, we get our x-intercept right here. So let's do, maybe skip every other one here. How did I do this? So we'll do like 5, 10, 15, and 20. And then 2, 4, 6, and 8. So I start up here at 20. Did I go up 2? 1, 2, 10, 15, 20. Oh, okay. All right, so I'm going to start here. And then we have 2 and 15. We have 4 and 10. We have 6 and 5. And then we have 8 and 0. And remember that this is the gallons, right? And this is minutes. All right. So what do you think? Does it make sense? Would I know how many gallons I had at 1 minute, or does it make sense to check how many gallons there are at 1 minute if I were to look at this, place on the X and travel up and try to meet the line? Yeah, you could do that. So, that would be a reason to use a straight edge and connect those dots, because we would graph the function and we would say it is continuous. And again, because of time, because the unit of time, because our independent variable was time. Okay, what about on 3? 3, we're talking about the input is the number of stories and the output is the height of the building. So when we're talking stories, we're like floors, right? If they have 1 floor, 2 floor, 3 floor, or 1 story, 2 story, 3 story building. And then this is the height and it's in feet. So when we're looking at the input, is it practical to have a continuum? Does it make sense to have 1.5? Would you be able to measure the height of the building if we had, this 1.5 or 2.5? We really don't look at that, right? We look at these stories or floors in a building to be discrete, because you can't have part of a story. You couldn't be halfway through that, doesn't make sense. So we could say that it is discrete because you cannot have part of a story in a building. Okay, you can't have like half of a floor halfway there, right? It doesn't make sense. All right, so I'm getting ready to clear, so go ahead and write this down if you need to write this down. All right, we're to the vocabulary and concept check. Again, identify which one you are responding to, and then if you have any questions about continuous and discrete, please leave that in the question slide and we can discuss it in class. Have a great night, and I'll see you tomorrow.